Hello everybody, my name is Jean-Marie DeJacker and today we are going to be looking at an acid-base chemical reaction between sodium bicarbonate and a dilute solution of acidic acid. In other terms, it's going to be baking soda and just vinegar. Normally when you hear about these two solutions coming together, you think about maybe a third grade science experiment with a paper mache volcano or even a rocket experiment. Today we are going to be looking at it in a little bit of a less creative style, and we are just going to be using a water bottle to get that done. But let's go over a couple things that we are going to be needing. We are going to be needing, of course, we're going to be needing our acetic acid, which is going to be our vinegar, We are going to be needing our baking soda or our sodium bicarbonate. We are going to be needing a clear water bottle or any water bottle that you might have. I'm going to be using a measuring spoon for the baking soda, and then you can use a paper towel as well, but I'm just going to be using your common tissue. But before we get started, let's look at different types of chemical reactions. So as we know, we have aquatic reactions. These are normally those that will occur in water, and then we will have our acid-base reactions. So aquatic reactions, in order to fully understand them, we need to take a little bit of a closer look at the compounds that are involved and see how they actually behave and react in water. So aquatic reactions will normally be involving compounds called electrolytes. These are considered compounds that can actually dissolve in water and can hold electricity or conduct electricity. If you have been an athlete, you are fairly familiar with this term because you find electrolytes within energy drinks such as Powerade, Gatorade. You can get Gatorade gummies now for electrolyte replenishment, as well as electrolyte tablets or even shots. From personal experience, they are not the greatest tasting thing in the world unless if they are in a Powerade or Gatorade flavored liquid. On the other hand, you actually can get strong electrolytes and weak electrolytes. So strong electrolytes are normally considered those that can actually disassociate all the way within an aqueous reaction, which means that they are completely that there's no ions that are left bonded together. And then you can have your weak electrolytes, meaning that they are partly disassociated from each other, but their ions will still remain bonded. Then you can actually get non-electrolytes. These are normally substances that cannot disassociate, and they can also cannot conduct electricity once the reaction occurs. But for today, we're going to be looking at an acid-base reaction, and a little bit about those is that acids are normally substances that will release an H+ ion within water or within the reaction, and then bases will actually accept the H+ ion in order to produce OH negative, which basically is an hydroxide. So it is also important to note that occasionally the base such as ammonia, which is NH3, actually will not contain hydroxide when the reaction occurs, but most bases will end up resulting in hydroxide. So, like other electrolytes mentioned above, you can get strong acids and strong bases, but today we are going to be looking at a weak acid and a weak base. So, let's get started. You will need your water bottle, so go ahead and open up your water bottle. You are going to then take your paper towel or your tissue, and you're going to be throwing some baking soda on it. I'm going to be doing a tablespoon. When that is done, go ahead and wrap that up all nice and neat. And then once that is complete, you're just going to be putting it in your water bottle if it fits. Let's wrap it a teeny bit tighter. it goes. Ooh. Like that. All right. Once you have completed that, you're going to be adding your vinegar and then just get ready to watch the reaction. So let's get ready. Oops. I also am doing this on a board just to kind of capture the reaction. And there you have it. There is our homemade exploding volcano. All right, so, oh, it's really exploding. There it is. All right, so what are we really looking at here? So when an acid and a base react, they actually go through a neutralization reaction. This means that the acid will actually donate that H+ ion that we talked about, which will then join with an hydroxide ion to form the base, from the base to form water. The anion of the acid and the cation of the base will actually then come together to form an ionic compound. In this experiment, the chemical reaction, of course, between sodium bicarbonate, which is your baking soda, it is also considered a weak base, and your acetic acid, which is a weak acid, your vinegar, will react to form two chemicals in this. So they will end up resulting in sodium acetate and carbonic acid. However, because carbonic acid is so extremely unstable, it will quickly disassemble in order to form carbon dioxide, which is that bubbles that we saw. As the acidic and basic reaction, normally it will continue until there are no excess H+ or hydroxide ions present. When all ions of one is completely depleted, the reaction, of course, will then be neutralized and will eventually end. This means that it is important to note that you do not need to do too much vinegar or too little baking soda. Your chemical reaction will be very small if this does happen. And to make the experiment a little bit more interesting, you can feel free by adding some detergent or a dishwasher soap in order to really see a bubble. But some errors that could go wrong is if you use a very thick paper towel, it could actually delay the reaction a little bit, which is why I ended up using a tissue to see that chemical reaction. And another thing is also just be aware of the expiration date that you do have on your baking soda, because a lot of the times the older the baking soda, the more effective it will become. I hope that you guys enjoyed this experiment as much as me, and I will see you guys soon.